small labs or departments, and get going. This is 300,000 of the 8 series are sold. Compare that to 120. Mini computers is a trend that's really starting up. Then you have competitors coming along. Back there on the chart, you can see there are tons and tons of mini computers. But a good example of the mini computers right here with the Data General Nova. Actually, a computer created by the guy who was the head engineer on the PDP-8 over there. He said, I can create a better computer, digital. His boss had said, no you can't. So he took this design and a couple of engineers from digital and started his own company. And well, he did so well with this that he became the #3 computer company in the world, right behind digital and right behind IBM. You guys have probably heard of IBM, but you haven't heard of digital or Data General because they're not around anymore. That's how quick computers are going to come and go. If you don't keep up with the rate of change, you're going to go the way of the dodo, or the dinosaur. So we have, over here, Digital Equipment Corporation, creating a computer that's very similar to this Data General over there, because that one was such a good computer, they figure, okay, well, here we go, we'll go with this one. We have video terminals coming out around the same time. 1970 was when the first video terminal came out from digital, and we also have it coming out alongside the 11 series. So this is a lot different than a teletype, right? It's not something that has all these gears. When you turn something on like a teletype, you can hear it running and humming. This is just like a computer basically, but it's not actually intelligent. They call these dumb terminals because they're responding to this computer. They're not working on by themselves. So this terminal is your way to interact with this. Rather than having all this paper around, rather than having all these gears around, it's preferable to your teletypes because it's really easy, doesn't require a lot of maintenance, and it's just a more easily understandable way to compute. So your video terminals are coming out. Your 11 series also propelled by the development of Unix. Now, Unix is an operating system that's the basis for, if anybody has Android or iOS or Linux, any experience with that?
Yep.
Well, Unix is something that you can thank for that. That's where time-sharing operating systems come from on mini computers, making these have a lot more capabilities. This is something that typically you would come up to, you could only have one person using it at a time. With Unix, you could have several people running the programs on it at a time, making this from one person to about a dozen people running programs on this. It made these a lot more useful. So between video terminals, better computers, and better operating systems, we sell about 500,000 of the 11 series. So more and more people are using them. Easier to understand, and you're going to see that that's a trend as we go along. The more people that can understand and use these computers, the more and more people are going to want to use these computers, to the point that everyone holding a computer basically right now, you guys have your phones. So we're still a long way from getting here, so bear with me. We have IBM stuff over here.
What?
And now, if you guys have experience with programming, you probably are using much more innovative and easier to use tools to program than you would have with this machine. But back then, you would program on punch cards like this. So you would make stacks and stacks and stacks and stacks and stacks and stacks and stacks of these. To run a simple chess program, you might have an entire shoebox full of these punch cards. So I hope you have fast fingers, and I hope they don't get tired a lot, because probably a lot of people that use these have arthritis now. It's a lot of work, and that's how you program your programs for a big machine like this. The IBM System 360 Model 91. And now this would be a much bigger machine if we had the entirety of it. We only have the light panel. So this is the one place that if you guys want to jam on some switches, go ahead and just play with these, because it's not going to do anything. Machines like this were used to help send people to space. As we see here, this is Goddard Space Flight Center for NASA. So you guys probably studied Voyager or Pioneer. Well, a computer like this helped send those things into space and keep that trajectory going right along. So all that information that comes back, well, you're going to need to process it. You're going to need big machines like this. Now, unfortunately, like I said, this doesn't work, but we're going to check out some working mainframes in the next room. So follow me on up the ramp.
Yes.
Then you guys are going to go off to your right. Try to do Xerox. Now you notice it's a lot louder in here. We have a lot of bigger machines pumping out a lot of energy. We also have the air conditioning cooling these things down. And you know how air conditioning happens, such as the way it is. So we have to deal with the dual threat of noise in here. So if you guys ever have any problems hearing me, if you gather up as close as you can, that'd be great. We have the Xerox over here. We show sometimes that just because you want to get into computers, sometimes it doesn't work out for you. Xerox, they had a lot of money from doing copying and printing. Xerox is a name that you guys have probably heard of because they're still around doing those types of things. But in 1969, they wanted to get into computers. Now, IBM was the king of computers, and they felt we have enough money, we can just compete with them by buying a company that already exists called Scientific Data Systems for $1 billion. And think about that in 1969 terms, that's probably worth about dozens of countries' gross national products. So this is a lot of money. This is a machine that is a defined machine, but came from a company that only had about 1% of the market share on mainframes. IBM sold so many of those mainframes, and other companies had already filled in the client base before Xerox had a chance to even enter the marketplace. So Xerox, 5 years later, they sold the remaining parts of this division to Honeywell for only $30 million. And you don't need a computer like this to know that $1 billion is a whole heck of a lot greater than $30 million. So, $1 billion down the drain, but this still exists. We have they're built on floors where you can if you can see through it, you can see the cables running underneath. We don't want all these trip hazards out here. We also have tiles that pump cool air throughout the bottom of these guys, so they won't overheat. You got the air conditioning going. It's a lot cooler room, so if you guys are having a hard day out in the summer heat, come back in here and just hang out in the air-conditioned mainframe room, and you guys can learn more about computers. Come on in. We have all sorts of different peripherals with this. We have memory cabinets and tape drives. But we like to show off the disk drives here because the price of having something that was 100 megabytes at this point, and that's what these packs are right here, these big cake-looking things, is to put it in a machine like this. It runs like a washing machine and a record player. It spins at 140 miles per hour. The heads come out and they read the data, but they're hovering over the data. So you don't want them to touch the actual data. So if this thing gets bumped, or if a bit of dirt or debris comes in between the head and the spinning pack, you're going to hear a screech. You're going to wave bye-bye through this carefully placed window. I mean, your data's gone. The head might crash like it did in this machine, and it's going to be useless. So, as it is today, it was back then. Back up your data, guys. Very important stuff.
Are the computers in our phones pretty much more powerful than these ones right now?
Yes, considerably. So, we're like all of the power that it took to get all of the space missions done, you have more in your phone. We're going to check out what happens when one of those drives crashes. So you can see on this, if it looks brown, it's fine, but if you see metallic glint, you can see that on this, that means that the head made contact with it, and the data has been wiped out. You can see the head's up close too. You can see that this one is bad already. It just has a little bit of the black on it. That's going even further. We have the more contact with it. And then this one, the head completely disintegrated inside of the drive, and this snapped apart. So the drive is down for the count. The data's gone forever, and that's a problem because we need to get this machine up and running. It's something that our boss over there, Paul Allen. There's a picture of him when he was about your guys' age, and then his buddy Bill Gates, who looks even younger than you guys, but is around the same age as well. they're in Lakeside School here in Seattle. They're learning how to program on a machine just like this. So we want to get this machine up and running because fellows like Alan and Gates are nostalgic about the work that they did on a machine like this, learning how to program. And we can simulate those experiences. If we get this up and running, people of all ages can get accounts and learn how it was to program on a machine like this. Of course, to get the power and to be able to allow many users for something like this, you're expected to have 30 or 40. Well, you're going to need a lot of chips. So you can see here, the older chips, flip chips with the individual parts. We can count the transistors on this, 1, 2, 3, 4. But we can't count them on this because these ones have integrated circuits. But there are hundreds of transistors. And more are going to be on each chip as it goes along. But if you look back there, Bill is testing the backplane for this. There's a whole ton of these guys, hundreds and hundreds, put in like this, and then those connectors all have pins coming out. So they're all wired up, and all those wires that you see are the individual chips communicating with each other. So that's what creates the CPU, the central processing unit, or the computer's brain. So use those for CPU and for the memory. So you're going to need a lot of these, and if they go bad, it's a good thing that they come out, right? Because then you can just switch them. I'm going to show you the next line of this type of computer. You can see that Keith is working on this particular one. This is the KL10, the third generation of the PDB-10. And so we have the usage of these ones. We talked about the computers being used for business purposes and science purposes. More than that, these are also used to create simulated environments to run software development. You can see Bill Gates and Paul Allen using them at Microsoft and trying to create an environment where they could create something like Excel or Windows. Using these machines is a lot easier than having a bunch of different workstations around trying to work on that. It's kind of a mess. You have it all contained in a computer like this. And if you guys like the internet, these computers also had a big hand in the development of that. Here we're using computers back in the day. No one uses that now. It's like MySpace. This is the place where you would have dialed into that. So, in addition to what people would standardly buy them for, people are finding all sorts of different uses for computers. Now, if you wanted to bring it to a smaller level, it's going to take a lot of work. This is code out for a reason. We're going to see the KS10 over here. It's the final generation of the PDB-10s, but it's a lot smaller. And because it's a lot smaller, it's a lot weaker. The KS10s are just a fraction of what you get out of one of these machines here. The architecture was such that it couldn't get smaller and cheaper and faster fast enough, so Digital decided to do away with the PDB-10s, and then a different company called Cisco, and you guys know them, right? Networking guys. They took on the project of making a PDB-10 smaller because so many people were using them, like Microsoft, in order to do software development. So Cisco, they did so well with their side project of networking. Of course, they're a multi-billion-dollar company now just on that alone, that they abandoned making computers. And XKL, the company that exists up in Kirkland, they're the ones that continued on with making a 10 smaller. They made the 10 on a desk, the Toad 10 on a desk. And even though this looks like more like a 10 is a desk, there's also just a lot of equipment wrapped around. See, these tiny boards are those computers boiled down to a much smaller board. So these 10 did get smaller. Unfortunately, it happened in 1995, so they only sold 4 of these. We have one. It's actually the first computer in our collection. Now, in order to get smaller, the guys at Tech, these are an entirely different computer. We see the VAX over here. The VAX 11780 is the first in a series of new computers that have varying degrees of architecture. So you can get a smaller computer over time. It'd be stronger and faster. You see that pizza box looking thing on the top? Well, that came out in 1991 and is a more powerful version of the one that it's sitting on. So computer development is going very fast, and now we're going to start seeing things really shrink down. But first we got to go back in time a little bit. Show you the last of it.
Shipping in the US and put it in
Photo up?
It scared me.
Alright, we see that we have another computer here that's a lot like the mini computers. That's because this one is your PDP-8 that we saw over there, plus the adaptability of a new computer called the Link. Now this is getting closer to what we're used to with our computers. Different ways to put in our peripherals, change that out really quick without having to wire all these things in. This is adapting to the needs of the marketplace. Most of the people that use these at this point were in labs, so the laboratory instrumentation computer, the Link, was the perfect computer to couple with the powerful 8, the PDP-8, and we have the PDP-12. Now you also have a data display here, and that makes sense because people want to see what they're doing. They don't have to add their own monitors in there. And so this is getting closer and closer and closer to the things that we're used to when we use a computer. But we're not going to get quite to microcomputers yet. We're going to look at this computer, the Interdata 732, and this picks up that Unix story. Now back in the times of these computers, your software wasn't something that you purchased from a company called Microsoft or something like, or games or any kind of different business. It was something that came with your computer or you programmed it yourself. So in order to change the way that people saw software and thinking about it apart from your hardware, you would need to look at the story from this computer. This is the first place that Unix was brought over to a different computer than a PDP-11. It was written in programming languages, and you guys might have some experience with those guys, but C was a big-time programming language at the time, but no one really had faith in it until Unix was brought over to a different computer. Now, all the people that were keeping an eye on this thought, okay, well, they just did the hard work for us. We have the ability to change these computers, their software, without having to program them ourselves. That takes a lot of the stress off the people that are using it, because they can just focus on what they're doing, running scientific experiments or doing their business data. If a program can be created from multiple computers, a lot of money can be made. So, start of the Microsoft story. And in case you guys weren't aware, they're very good at making money off of software. And they start because of the innovations of bringing a computer into your home. Now, microprocessors are something that we're all very used to using. It was a very new idea in 1974 when this computer came out. The Alto 8800 contains one of the first microprocessors, the Intel 8080. And this gives you a way to compute at home very cheaply. It's not a very powerful computer. However, it is a way to do some of the things that you would do on a massive computer that we saw before for only $400. This is wrapped around that Intel 8080, but it also needs a way to talk. So you can also flip the switches if you want to talk to it that way. But since you probably won't understand it, it's best to have something like a teletype here. So in order to communicate with the computer through the teletype, you're going to need a language. And the first product that Microsoft is developed here. You can see early Microsoft employees, they were responsible for creating Altair Basic, the basic programming language that would be used for communications with a machine like this. So the first product of Microsoft comes along as a result of the microcomputer revolution, and Microsoft actually gets founded in Albuquerque rather than up here where it belongs, and it's all because you can compute in your home now. Now that's going to make software and hardware an even bigger market. We're going to see what happens with all that around the corner. all sorts of microcomputers. Now these are, yes, called microcomputers. Later on they'll be desktops or PCs or just a computer as people refer to them now. But early ones are kits, like that Alto back there. It's something that you'd have to piece together yourself, or it's kind of bulky. You put it with a terminal or a teletype, something like that. And later on, you're going to see the monitors and the CPUs all in one. You have Radio Shack and Apple, and then later on, the first video game systems are created through the use of microprocessors as well. Atari, Commodore, things that aren't around now, but these are the predecessors to Nintendo and to Xbox. So all of the innovation of getting computers into your home is happening in this era. Now this is going to be a place where I'm going to unleash you guys and you can play games later. We have just a little bit more to go. So where are all the innovations that are going to bring us to using the computer very simply? Well, they're coming out of this rarely seen computer, the Alto. Now, you guys probably never worked with a Xerox computer, and it's because they weren't very good at selling computers. We heard about that a little bit in the Mainframe room. But this one is a very innovative computer. It's the first place that you'll see a graphical user interface. First place that you'll see the use of the mouse of the computer. First place that the Ethernet is created in order to network all these computers. And also, it's the first place that if you print out a document, it's going to look exactly the same way as it does on the computer. So all the things that we take for granted coming out of this project. Fortunately, these things cost $32,000 to manufacture. That's just to make, they never sold them. So they only made about 5 of them, and not 500 of them, and they spread them around to a lot of different institutions, trying to get younger people to learn how to compute in this way, trying to get people that work in offices to think that this was the way they use a computer. However, they could never find a way to make it much cheaper. By the time that they sold these in the early 80s, they were $17,000. And all the computers that we just saw were a whole heck of a lot cheaper. So, we're going to check out where all these innovations really come into play in a little bit. But first, we got to see IBM. You know that they're the king of computers? Well, when they entered the market, it made it really safe to buy a computer. If IBM was selling computers, well, you could really trust that these were good machines. IBM decides to make the personal computer. They don't think that it's going to sell too many. And I think the mainframes over there that we saw were going to be the way that they made most of their money. And so they didn't have the foresight to think that this was the future. Well, IBM, they allowed Microsoft to keep the license for the operating system for this guy. PC-DOS would become MS-DOS. And then Microsoft got a lot more money out of the ability to sell these operating systems to whoever they wanted that had the right technology. Now Microsoft, we're going to get back to the story in a second, but all those innovations that we saw at the Alto, they gained popularity over here with the Macintosh. This is an affordable, portable, general purpose computer, just like we thought about 7 back there, but this is even more so. This is a $2,500 machine. Carried around in this bag with it, and it all had